Happy Wednesday, metalheads, and happy whatever day it is if you're joining us via recording from the future. If you're joining us in real time, you can provide questions, comments, and any other flavor of love via the chat. That'll be on the YouTube, on Twitch, on Twitter. And today we'll be talking a little bit about what's required to bring up the infrastructure to test Tinkerbell, a open source project that is now in the loving arms of the CNCF that provisions bare metal infrastructure. Joining me is my teammate David.
Hey, Jeremy.
Good afternoon for you, I believe it is.
It is 7 minutes past 4. I don't know if that's afternoon, evening, or something in the middle, but yeah.
What do you call it there?
The void, I guess. That really frustrating time. It's like it's after lunch, you've still got work to do. It's not the end of the day, but you just got to keep giving.
Didn't know if it was one of those like 5:30 things. I never know if that's before 5 o'clock or after or half past.
Yeah, so half. Do you know the phrase "the back of 5"?
No.
I think that's a very Scottish thing. And actually, what we'd say in Scotland is the back of. So it'd be like the back of 5, which means 5:15. Which means the back of, but not half past. There you go. There's your random bit of trivia for today.
Perfect. So you had done some work on the infrastructure providers that work to set up test infrastructure for Tinkerbell, yes?
Yeah, that is right. So our mutual colleague, Gianluca, is a contributor and a maintainer of the Tinkerbell project. And I think they were running into a little bit of a problem in that they wanted to be able to test the Tinkerbell, but it's not something you can really test with traditional continuous integration delivery frameworks. And that, Tinkerbell is there to provision bare metal. And in order to test it, you need access to virtual machines and DHCP and Pixie booting and all this other random stuff that you can't get just by spinning up a container and saying, hey, go at it. So Gianluca is, he's always solving problems, right? He just spun up his own self-hosted runner and that lasted him for a while. But he reached out to me and was like, hey, we probably want to automate this. And I was like, yay, like I want to use these tools and I want to do this. And he gave me free rein to go ahead and do that. I had a bit of fun, and I'm hoping I can kind of show that off today about the decisions and why we made them, etc.
Yeah, we'll love to see.
That's my cue, right? Share my screen. All right, let's see. It's all open source, of course. Everything we do is open source. It's on the infrastructure repository, and I would love to say it is well documented, but it is not. That is definitely something that is on my I promise I will fix this list, which grows by 2 things every day, and I cross off, half of one every other day. So you can see how well that's going. Now, because this is infrastructure as code, a lot of people go to the same set of tools there, which is, maybe Terraform or Pulumi. I'm more inclined to use Pulumi for a few of the reasons it will cover as I walk through the infrastructure. And there's a bit of an amusing story. I wouldn't say funny, but it is an amusing story. And that I wrote all of this in Pulumi using TypeScript. And one of the really cool features of Pulumi is that you get to use the language that you're more familiar with or you enjoy working with. But it turns out the Tinkerbell team are not familiar with TypeScript. So I did a bit of a rewrite to Go. Was interesting. I'll show off some of the quirks they use in Pulumi and Go as we walk through it as well. But of course, Pulumi's only... this is where I'm going to get really dogmatic. Like, Pulumi is really good, and Terraform is good at this too, at giving you the thing, right? I want a machine, give me it. I want a resource in the cloud, give me it. What a lot of people try and then shoehorn into all of these systems is then the ability to run scripts and configuration management through Pulumi and Terraform. And I'm very... I don't like that approach. I think it provides a whole bunch of constraints that aren't conductive to a healthy infrastructure as code relationship. So I also brought in some salt stack for this. So we do run a salt stack cluster with one master node, and each of the runners is a minion which does the bidding. So it works really well. They work together. I'm going to try and see if I can show this off in the next kind of 15 to 20 minutes. Any questions on that so far? But the tools, the choices, anything I should explain before I dive into code?
Maybe a little bit more about Tinkerbell and why it can't just be run in a Docker container.
That's a hard one, man. Come on. No, I'm not. I don't have really great knowledge of what is happening on the actual testing layer, but I know that virtual machines are a very strong candidate. Like, part of the Tinkerbell infrastructure, or the testing part of it, is that it has to spin up virtual machines, which then speak to a DHCP server. They get an IP address. They do a Pixie boot from it. All of these things, I think, are really difficult to do in container land because of the permissions required and a whole bunch of other constraints. Not very familiar with, but I don't think it would work in a straight up container environment.
No, and the thing that you're testing is the ability to provision bare metal, and so if it and trying to get away from it'll probably work too. So you either need to have your own lab to test that, which is the one thing, or you need access to some sort of service with bare metal, and if you're don't have credits for the open source project, then that costs money to try it.
Well, yeah. I mean, if we remember that containers shared the kernel with the host, and what we're trying to do with these virtual machines is run our own operating system with its own kernel, with DHCP, with iPixie. Like, there's just a whole bunch of things there that they just wouldn't work that well. So yeah, virtual machines are definitely the way to go. And spinning those up in traditional continuous integration environments would be probably quite slow and painful. And we work for Equinix Metal. We have some pretty beefy hardware lying around. Like, why not use it, right? So we can do that for the Tinkerbell project. It gives them a test environment that's hopefully fast and performant and does what needs to be done. Okay, so let's start with. I guess we should start with the Pulumi. So I know the sidebar is going to be a little bit small, but the code should be all right. How does that look for you, Jeremy?
Readable for me.
All right, I'll take it. So this was actually my first venture into writing Pulumi infrastructure in Go. There were some pluses and some minuses. One, I was familiar with Go, so it wasn't too difficult to pick up. However, there are some little weird behaviors the Go SDK for Pulumi kind of expects you to get to grips with. One of them is that strings all have to be wrapped in Pulumi string. Not something I had to do in the TypeScript API. And of course, this is Go, so you're going to see a lot of if error not equal null, return error. Like, error management is something that has to be handled at each step as we request the resources. So this Pulumi code is responsible for managing a few things. First of all, it will manage the DNS that we need to access the test infrastructure. One of the things that was important to me when I was building out the automation for this was that we commoditized the access. All that means is that Tinkerbell is not owned or governed by Equinix Metal. It's owned and governed by the CNCF as a sandbox project. And that means that I don't want, even though we host this infrastructure on Equinix Metal, it is hosted on the community infrastructure lab provided by the CNCF, and we want people at the CNCF to be able to access that as well. And because it's an open source project, we actually want anyone with the correct permissions within the Tinkerbell organization should be able to have access to the machines if they have to get on it to debug their pull request, their test run, etc. So there's actually another piece of software brought in that I forgot to mention at the start, which is teleport. And if I've not broken anything, should be able to browse it. Nice. I've been making tweaks to this infrastructure all week, so there's always there could be some rough edges today, that's for sure. But teleport means that we have it configured, and we'll see this in the Pulumi as well, in the salt stack, that anyone that is a member of a certain infrastructure group within the Tinkerbell organization on GitHub can access the teleport instant, click the button, and boom. We have access to only one machine. There's probably one of those rough edges that I'll need to fix after this session. But this is a really cool tool. Teleport is it's just really cool, to be fair. Like I have this web-based terminal access to the servers. I can get on, do what I have to do, and then drop back off. When we close the session, we have the ability to go to activity. Uh, we can see if there were any active sessions. We can see the old session, and I can replay it. So it's not just from a commoditization aspect of, yes, we do want to give people access to this to have the relevant permissions within the CNCF and the Tinkerbell project, but we have this extra layer of security and auditability, and that we can actually see what had to happen on the machines. Good for disaster recovery too, if it should ever come to that. But of course, this is all mostly stateless and can be killed and destroyed at will. So teleport is very nice.
That keeps you from managing a large pile of keys, though.
Well, yeah, that's what the position we don't want to be in an open source project is, we get a new contributor, they start to contribute more. We want to give them access to help debug their own tests in the production environment or the CI environment at least. And it's not shipping, oh, what's your SSH key? Okay, let me add it to this box. Oh, I need access to that box. All right, okay, let me go do that. Right? This is almost a nice civil way of handling it. So really, really happy with it. So yeah, I got a bit of a segue there, but our Pulumi code does manage our DNS, and that sets up our teleport.tinkerbell.org system for that community to come in and do what they need to do. We then create the salt master, and then we create some GitHub runners which register with GitHub, and we have access to those self-hosted runners that are GitHub Actions workflows. I think that's the correct terminology. Can allocate jobs to those runners. All works nice. Tinkerbell is also in a transitional period of where they're now starting to provide additional tooling to help facilitate image building to make that easier. And with the idea of being to provide a common location or artifact hub store where people can come in and say, I want to deploy Arch Linux, I want to deploy Windows, I want to deploy anything else using Tinkerbell. And we have these images available that can be consumed without necessarily having to build your own. So we also set up some DNS records that point to an S3 bucket that is provided by Cloudflare that is replicated around the world, so people have fast access to those images as well. Something that is currently being worked on and will roll out soon. Okay, so what does the DNS look like? So obviously I don't have access to the root keys for the DNS, so I'm really just using the data API within Pulumi. This is very similar to Terraform to look up that zone on the provider. And then I pass this back as an infrastructure property that can be consumed later for for the other components to then say, hey, I actually want to create a record. So not very exciting, but has to be done. Then we've got the salt master logic, and here we're consuming. One of my really strong goals for this was to make sure that not everyone on the Tinkerbell team has to have a degree in Pulumi. Right? I just want them to be able to come and interact with this in a really simple fashion. So you'll see that I load a lot of things from the Pulumi configuration, and that's so that I can give a YAML interface to Gianluca and to everyone else on the Tinkerbell team. So if I open the Pulumi production, you'll see that if they actually want to add new runners, they have this really small subset of YAML that they have to interact with, and they don't need to dive into the Pulumi code if they don't want to, right? If they don't want to change the behavior. Here you can see we've got two runners. We've got one in AM6, that's a C3 medium. We can tell it that we want to target some states. So our AMD 64 instance does have to have Vagrant on it for some of the test cases, whereas that has not been used on our ARM device. And just because I'm feeling particularly brave, so I don't we just add one. I've seen that look on your face, Jeremy. You were like, we had not talked about this. We could add a C3 medium x86. And just so people can see how this Pulumi works, is that I can run a Pulumi. I could type
there you go.
A Pulumi preview. And I'll leave this one. We'll confirm the preview first, and then I'll leave the apply stage running as we walk through some of the rest of the code.
You were saying it wasn't going to require a degree in Pulumi, but I think, were you granted the Pulumi degree? Are you now a Puluminati member, or what is the?
I don't think that's public knowledge yet, Jeremy. I think we said nothing. Okay, our preview here does actually say that we have an equidictmental device, so we're just going to go ahead and run a Pulumi up. Again, it's I haven't told it not to do the preview. I probably should have done the Pulumi up anyway. It's going to then ask me to confirm these changes. I will click the yes button, and then we'll jump back into the code. And we have a comment from Thomas Stromberg. Hi there, maintainer of the Minikube project. And your honest opinion, reliable infrastructure testing is rocket science. Yeah, it's always a fun problem to try and crack, that's for sure. Okay, let's see. I have now hit the magic yes button. I'm going to ignore that for the next few minutes. There's more configuration in here. There's secrets in here. That's another really superpower of Pulumi, is they have inbuilt secret management, which means I can get ops all of the stuff. But I'm not going to touch on that too much today because I'm not entirely comfortable revealing all of that on the screen for too long, even though you can screenshot it, but it's not. It's good. I'm sure it's fine, right? Okay. So if we pop into this Saltmaster, you can now see we're just throwing around data structures about what we want to get out of this system. We have some AWS configuration, we have some GitHub configuration, we have our teleport configuration. All very, very uninteresting. Whenever possible, I load this from the YAML interface rather than relying on code and hard-coded things. We assign an elastic IP, we set up some teleport stuff, and this is going to feel familiar to anyone with Pulumi experience or even Terraform experience, right? We're just defining our infrastructure as a collection of data structures and then having Terraform and Pulumi build a graph and then apply that whenever possible. Now, the only thing that is slightly different here is that I'm using a Go interface to Cloud Init, which I particularly, I don't know if I'm feeling strong enough to say enjoyed using, but definitely better than slinging around random strings. So we do have to be able to tell this machine when we spin it up that we want to install a Saltmaster. So if we click on the Cloud Init configuration, you can see, I think it comes from the Juju project at Canonical, so thanks to them. But I have this really nice interface to say, yes, I want to run an app update or a yum update on the system. Yes, I want to run this command to install. Yes, I need to provision some files, and I just drop these in using template or string literals in Go or TypeScript, etc. And this does all of the configuration to get the machine up and running. You can see here, I'm just telling Salt to bind to the private network. Of course, I'm not going to make that public. I'm not an animal. We set up some services. We enable both the Saltmaster and the minion to run, and our job is done. That is it. We do the same for each of the runners. They are just another bare metal machine that runs a Salt minion that speaks to the master and works out what they have to do. Let's close that down, and then that just handled here. Pretty much the same code. They've got slightly different roles. We use this on the Salt Stack side to be able to determine what we want the machine to do. Really trying to make sure that we don't hard code or confine ourselves into any bad patterns. And then we create the DNS or the Cloudflare and the S3 distribution for serving the assets. That's kind of the Pulumi side. It's not complicated. The YAML interface is there, and it's all open source. So hopefully this is a good reference for anyone else that wants to start their Pulumi journey with Go. And we can see that was quite nicely timed. That was definitely not planned, but we actually we have created our new resource. We do have our runner 2 here, and I'm not sure how long that's been, but what we should see, if I click on settings and actions, we should be able to see a list of our runners. Okay, so we don't have runner 2, but that will be there in a few moments. We can see the label was applied to this one here with the Vagrant, the ARM one did not. I don't want us to turn into like a Pulumi advertisement, of course, but they were very kind to the Tinkerbell project. They have given us a free account, which allows us to rely on storing state in their cloud-based service, and it also gives anyone with the, again, appropriate permissions the ability to come in here, see what happened, when it happened, what resources were created, etc. So a really nice system. All right, now any questions on the Pulumi side before we move on to the after the infrastructure as code side and onto the configuration management?
None from me. Internets? Quiet on that front too.
Got it. All right. So we spun up the machines. Now the machines need to know what the hell they're supposed to do. The Salt Stack is definitely my go-to tool here. I just think it's a really good system. It scales particularly well. I like the communication method of using Salt Stack. They really nailed that compared to other configuration management tools. By that, what I mean is that our Salt Master node runs on a machine, exposes itself on one of the interfaces, and then the minion nodes all just have to be able to speak to that, right? The master node doesn't reach out to the minions to try and initiate any orders. It does it all over an event bus, 0MQ. It publishes messages to the bus, the minions consume them, and do what they have to do. It makes the firewall rules a lot simpler, makes the security a lot simpler, and it's really, really fast, right? The minions can concurrently and independently do the jobs that are assigned to them. It's got a YAML interface. This is, the cloud native and DevOps renaissance. Everything is delivered via YAML. You can see here that for Docker, I can use package installed manifests here to say I need these packages to be installed first. I then want to add the Docker repository. I want to install the Docker packages. I want to ensure the service is running. And then I just want to make sure containerd is running too. So, the idea being anyone really could come in here and add new steps to this. And you can ramp up on your Salt knowledge pretty quickly, at least from the consumer side. GitHub Actions is pretty much the same. We have a few states here. We've got the ability to make sure that the GitHub user is on the Docker group. We make sure the directory exists. Unfortunately, they're not shipping the Actions runner over a Debian or a Yum-based repo. So we do have to download the release from GitHub itself, extract it, and run it. But again, Salt provides all the constructs that we actually need to do that without jumping into really imperative code, which I think is a really good selling point as well. We then have the ability to register a runner. We're doing that through an API lookup. This is all delivered secretly. So, the open source repository is not giving away any of those credentials, which is fantastic. We register the runner with the GitHub service, and we apply any labels that we need, and that's it. And then the state list that we had on the YAML interface to the Tinkerbell team allows them to pick and run any of these states within this directory. And you can see that we have the Vagrant one. And all it really has to do is install Vagrant and VirtualBox, and its job is done. Everything is happy. We can see that there's a Salt state here for deploying teleport, not telegraph. Again, very similar to everything else that was seen. And we use Let's Encrypt for the certificates, and the job is done. Now, let's see. If we grab the IP address for our Salt master, we can actually introspect the new runner and see if it worked. I mean, I'm not holding my breath, but so we're on this master node. We can do a escaping star to just say we want to ping all of the infrastructure. We can see here we got a very fast response from the minion that runs on the master node itself and from each of the runner nodes. One of my really cool things, so not really cool, one of the things I like to show off with Salt is that we can execute any arbitrary command on each of these machines. We can run a PS, it's a really nice way to interact. It's maybe not important at 3 machines, but when you're getting to 20, 100, 1,000 different machines share infrastructure, you want this kind of flexibility and power at your disposal. All right, how do we feel? Do we feel that we're going to have a new runner on this list? Are we taking bets?
I'm going to put it at 75%.
I see the number 4. And we do have our extra runner. So I personally feel that is a job well done. I'll pat my own back here. But, been able to add 3 lines of YAML to a system like this and giving people the ability to configure their own runners, add their own states, deploy their own software, commoditizing access through great tools like Teleport, SaltStack, and Pulumi. Is just the right way to build infrastructure as code, configuration management, and open source technologies in 2021. That's I'm impressed with that.
Well, it certainly wins the bake-off against. I'm trying to think of the old version, which may be like tickets on top of asking someone for a password, on top of That a much longer, angrier list of pains.
Yeah, I mean, we've all survived 2020. We're now reaching into 2021. We want to make our lives easier. Distributed remote teams, open source software has always had this, and the processes have been cumbersome, I think, over the years. And been able, it's tools like Pulumi and Teleport and Terraform and SaltStack and Chef, etc., that when used right and applied correctly, can make this a lot easier for us all rather than a burden. We don't want to be in a position where things are painful. Like, we want Tinkerbell, and I'm going to say we. I don't think I have the right to say we, but I'm going to say we. We want Tinkerbell to be open, anyone to come and contribute. We don't want there to be blockers. We don't want it to be frustrating. We want it to be easy. We want it to be fun, if possible. And I think this is a good step in that direction. And testing is not a part of an open source project that people enjoy doing it anyway. So why make it harder for them? Let's hopefully make it easier for them. At least that's one of the goals.
Okay, and then from here, what's our next step? What would we do with all this? You don't have to do it. Just tell me a little bit about it.
I'm not sure what exactly the next steps are. Like, there's no, like, it's not mostly, it is stateless right now. I can and often run Pulumi Destroy on all of this and spin it back up. It takes around 10 minutes. I'm very happy with that. But, there's no not reconciliation is the wrong word. Like, if things go wrong, there's no way to be alerted on it now. There's no monitoring on these systems. So, I do want to run InfluxDB on it. I do want to get metrics out of it. I do want graphs and Grafana dashboards and be able to increase the visibility into this. Because, I think we're in a position now that as the team begins to use these new self-hosted automated runners, is that, yes, Teleport lets them get on it to work out what's wrong, but they still have to do all their own digging to work out, well, why is it not working? Like, is the CPU load too high? Is the memory consumption exhausted? Is the disk about to fill up? Which, in a CI environment, probably 9 times out of 10 might be the case. So being able to then give them a dashboard that they can hit before they resort to actually SSH onto the machine is definitely something that I think we'll tackle in the next days and weeks, maybe. Hopefully not months, hopefully much quicker than that. But just to give them that idea that, well, the machines look okay, they're not overloaded. Do we need to auto scale them? Do we need more runners? Like, there are all these things, these next steps that I think will come in very soon.
Yeah, I saw the names of plans and facilities drop down into the YAML there, and yeah, an understanding of which plan might work best for the testing that's being done would be, I suppose, a place to go and explain further.
Yeah, I think as support for operating systems begins to change, as they do more with Windows, maybe they start to do stuff with Macs, maybe they do stuff with slightly more esoteric Linux distributions, or even crazier stuff than that, who knows, homemade operating systems. But they may need different hardware, they may want to test GPUs, they may want to do all this other stuff, and I think that will enrich the YAML abstraction as those requirements come in. I certainly haven't jumped ahead of the gun too much to add too much there yet. And I think the salt states will build out as well. Right now, you can say, I want to run with Vagrant and VirtualBox, but we're going to need runners that have other tooling probably sooner rather than later, and we'll start to build out those salt states as well, I would imagine. I don't think I have anything else to show.
No problem. Yeah, if folks want to see more, I think that's at Tinkerbell/infrastructure then?
Yeah, it is. There are a couple of open issues, and I will do my best to add more. Oh, I can close this one. The first iteration of this did run the GitHub Action runner as root. Of course, I know that was not good. That has now been fixed. We are having conversations about whether Go is the right language to use for the Pulumi automation. Those will mostly happen in internal, but we will externalize them now. Just because there are those random things in the language that don't make it ideal. Let me show off one of those things. So, let me say something bad about Pulumi, because I always say something nice. All right. Yeah, so you can see here that Pulumi.string thing I mentioned earlier. Like, you can't just use traditional Go strings when you're passing these around, because they get wrapped and sent as a pointer. it just makes it difficult and confusing to new people. And I think adopting another language may ease that for people. And then there's also this very weird high order function for late binding that has to encapsulate resources that don't exist yet so that you can inject details that will exist. A good example of that is inside of our user data for is this the minions? Oh no, okay. Inside of the user data for the Salt Master node, we need to be able to pass in a secret for the peer token. But of course, that machine doesn't exist yet, and we're waiting on a resource to be created, and then we have to wrap it in this function. Very weird. Sadly, this is something that is difficult across all the languages in Pulumi, but it's particularly more frustrating in the Go ecosystem, and a little bit easier in the TypeScript. So yeah, that conversation is ongoing. We'll see what happens with that.
Yeah. If you'd like to join those conversations, most folks are in the Tinkerbell channel in Slack. That's slack.equinixmetal.com. And then also, Twitter is a great place to field questions also. This is Tinkerbell_OSS.
All right, awesome.
You can chuck those down into the show notes for our future friends. But with that, I think that's our Wednesday. Good evening or whatever it's slipped into over there. Are we at the back of 11 or well deep into 4?
We are 4:45.
Quarter. Okay, I'll take it. Bye for now, David. Bye for now, metalheads. We'll catch you before long.
Thanks all. Bye.